Hello everyone. Now we are going to discuss about the surface areas and volumes of three-dimensional objects. In this video, we will be learning about different terms which are going to use for the measurements of three-dimensional objects. And also we will discuss about the types of the objects which we are going to discuss in this particular chapter. Here in this video, first we have solids. What is a solid? A solid is an object which occupies space. The solids are generally three-dimensional objects. Like we have a cuboid, cube, cylinder, etc. Then we are coming to the total surface area of a solid or three-dimensional object. See, every object, every three-dimensional object, every solid has some surfaces. If we find the areas of all the surfaces and add that, we will be finding that as the total surface area. So we can say the total surface area of a three-dimensional object is the sum of the areas of its all the surfaces. Like we have a cuboid. This is a cuboid. Three dimensions: length, breadth or width, and the height. We have here 1, 2, 3, 4, 5 and 6. 6 rectangular faces. If we find the areas of all these surfaces and add them, that will be the total surface area of this cuboid. Like we have a cylinder. In case of cylinder, we have 3 faces. One is this is known as curved surface, and these are circular faces, top and the base. If we find the areas of all these 3 faces and add them, then that will become the total surface area of this. In case of a sphere, this is a sphere. Ball is the best example for a sphere. In that case, we have total surface is curved. It means if we find the area of this surface, that is the total surface area, or we say curved surface area of a sphere. It means in case of a sphere, the curved surface area and total surface areas are equal or same. Now we are coming to the lateral surface area. What is known as lateral surface area? For cubes and cuboids. See here, this is a cuboid. If we find the areas of all these 4 faces and leave the top and the base, then the areas of these all 4 faces, if we add, that becomes the lateral surface area of this cuboid. It means we can define it: lateral surface area of a cuboid or cube or a solid is the area or sum of areas of all the surfaces of it except the top and the base. This can also be said to be the area of 4 walls, like a room is a cuboid. If you leave the area of the ceiling and the floor, the sum of all the 4 walls is known as the lateral surface area of that room. It means the lateral surface area and the area of 4 walls in case of a cube or cuboid is same. Then we come to the curved surface area. Like we have seen here in the case of cylinder or in case of a sphere, we are finding the surface is curved. This is in cylinder, this is a curved surface. If we leave top and the base, the area of this only curved surface is known as its curved surface area. So in case we find the total surface area and subtract the area of the top and the base, area of these 2 circular faces, that will be its curved surface area. And in this case of sphere, we have already discussed that the total surface area and the curved surface areas are same. So curved surface area can be defined as the area of the curved surface of a solid or of a three-dimensional object. Now the volume. What is the volume of a solid or three-dimensional object? That is the space occupied by it. We can also say that if this is a cuboid, how much different items can be placed in this, or if we fill it with some of the liquid or some of different items, then how much will be the quantity of that item which is contained in it is also known as the volume. When we talk about the liquid, any of the liquid, when we are filling in it, how much liquid can be contained, that is also the volume of this particular object, or we say that of the cylinder, or it may be any type of object or any type of solid. So when we discuss about the units of the volume, we can see, since there are 3 dimensions, we will be multiplying that 3 times, any of the unit 3 times. Like in the areas we were multiplying twice. Centimeter into centimeter was centimeter square or square centimeter, the unit of the area. In case of meter, it was meter into meter, that was meter square or square meter. Same way in case of volume, we will be multiplying 3 units like centimeter into centimeter into centimeter. So this becomes centimeter cube, or we call it cubic centimeter. In case the dimensions are measured in meters, then it will be meter into meter into meter, or we say meter cube. Or we can also say it as cubic meter. Now, as I told you that volume is also containing some of the particular liquid, and generally we measure the liquids in terms of liters. So how much is 1 liter? 1 liter actually is equal to 1000 centimeter cube. It means in case you are finding the volume in cubic centimeter or centimeter cube, divide it by 1000 to convert into liters. Now suppose we are measuring that in meter cube. Then you can see 1 meter cube is 1 meter into 1 meter into 1 meter. It means that will be 100 centimeter into 100 centimeter into 100 centimeter. Can we say it is equal to 10 to the power 6 centimeter cube? And this is 10 to the power 3 centimeter cube. It means in case we want to convert 1 meter cube into liters, how much will be that? That is 10 to the power 6 centimeter cube. Can we say it is 10 to the power 3 whole square centimeter cube? Now if we want to convert into liters, will it be 10 to the power 3 square upon 10 to the power 3 liters or not? And it becomes 10 to the power 3, or you can say 1000 liters. So please remember that 1 liter is equal to 1000 centimeter cube and 1 meter cube is equal to 1000 liters. The forms of the 3-dimensional objects or solids which we are going to discuss in this particular chapter are cuboid. We will be learning about these all forms in detail one by one in the coming videos. The first one is cuboid. Cuboid actually is a solid having 6 rectangular faces. The length, breadth and the height are different. Cube. A cube is having 6 square faces. It means its length, breadth and height, all the 3 are same. The sides are A each. Right circular cylinder. A right circular cylinder can be formed by revolving one of the rectangular sheet. Looks like this. This is the radius of the base and the top, and this is the height of it. Then the right circular cone. A right circular cone can be formed by revolving one of the triangular sheet. The best example of this is a softie. Here this is known as the radius, this is the height, and this is known as the slant height. Sphere. Sphere actually can be formed by revolving a circular sheet. Like if you revolve a coin on the floor in the standing vertical position, you will find it forms like a sphere. Then hemisphere. Hemisphere actually is half of the sphere. Like you are finding bowls at your home. They are hemispherical. Then comes frustum of a cone. If we cut a cone by a horizontal plane, when it is kept in the vertical form, then the lower part of this is known as a frustum. It looks like this. Bucket in your homes are the best examples of the frustum of cone. We will be discussing about these all one by one in detail in the coming videos. And in the next video, we will be learning about the formation of these solids or three-dimensional objects by a revolution. How can we form this? We will see it practically also, how we can form and how we find that it is forming a cylinder or a cone or a double cone or whatever it is. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.